welcome back. We're going to take a look at setting up an initial tableau for a non-standard minimization problem. First, let's figure out why this is a non-standard minimum. The main reason this is a non-standard minimum is because the inequalities are not all pointing the right way. So for example, if you look at the first constraint, the inequality is going the wrong direction for a standard minimum. If you look at the third constraint, we have an equality instead of an inequality, and so that's a problem as well. So this is a non-standard minimum problem. So we're going to have to address the non-standard minimum problem by essentially creating a maximum problem. So what we're going to do is we're going to create a new objective function. So we're going to maximize, and let's go ahead and call it W, so it's not the same letter. We're going to maximize W, which is going to be the opposite of Z. And the reason that this works, so if you think about, let's say we think about like a parabola, y equals x squared. If I want to find the minimum of y equals x squared, this is going to be down here on the vertex at the origin. Well, what if instead we graphed negative x squared? Negative x squared would be the same graph, but flipped over. And so now the point that used to be the minimum of x squared is now the maximum of negative x squared. And so that's sort of the idea that we're taking advantage of here. If we want to minimize z, we'll go ahead and maximize negative z. And the reason we need to change this to a maximization problem is so we can apply the simplex method. Okay, so we've got to maximize negative z, so let's go ahead and write that down. So we're going to maximize W, which will be equal to negative 7x1 minus 3x2 minus 5x3, because it must be negative of z. Okay. Now, since we're trying to set up a standard maximum, we would like the first constraint to stay exactly as it is. It has the correct inequalities, everything is positive, no big deal. So we're going to maximize W subject to, and let's see, the first constraint will be unchanged. Oh, not negative. Here we go. 3x1 plus 6x2 plus 8x3 less than or equal to 72. No problem. Now the second inequality, the second constraint, is pointing the wrong direction, right? We want the inequality to be going the other direction. So what we'll do is we will multiply that entire inequality by negative 1. Multiplying by negative 1 will flip the direction of the inequality, making it the correct type of inequality for a standard maximum. So our second constraint will become negative x1 minus 3x2 minus 2x3 less than or equal to negative 40. Okay, so now we're getting closer to the standard maximum. Now let's take a look at the third constraint here. The third constraint is an equation, an actual equality. And so let's think about how could we take an equation, an equality, and somehow get an inequality out of it. And that comes from this idea. So if x, let's say x is equal to 7, okay, then this means that x has to be less than or equal to 7, and it has to be greater than or equal to 7. Because if x is less than or equal to 7 at the same time as being greater than or equal to 7, then it must be that x is actually equal to 7. So we'll use this same idea for our equality. So let's keep looking at the simple, the x less than or equal to 7 idea. This tells us then that we would have one constraint, x less than or equal to 7, and another constraint, x greater than or equal to 7. Now this second constraint, the inequality is pointing the wrong direction, so we would do the same thing that we just did. We'd multiply by negative 1. So negative x will be less than or equal to negative 7. And then we can go from there. So let's use that same idea on this third constraint that has the equal sign. We will get one constraint, which is exactly what we have with a less than or equal to 56. So we'll have wrong color. We'll have 3x1 plus x2 plus 5x3 less than or equal to 56. And then we will also get a second constraint. So we'll need to take the opposite of what we have, and then it'll be less than or equal to the opposite of 56. So our second constraint will be negative 3x1 minus x2 minus 5x3 less than or equal to negative 56. And of course, x1, x2, and x3 are all still required to be greater than or equal to 0. So now we have a standard maximum problem. We have a couple issues here because we have some negatives on our constraints, but that's something that we'll look at when we actually go through an example, solving a non-standard minimum. So that'll be the next video. So for now, though, we can go ahead and set up our initial tableau. So our initial tableau, let's see if I have room down here. Oh, I do. Good. Okay. So we'll start with the x1 column. So we'll have I'll start with constraint 1. So we'll have 3, 6, 8. Now let's see, we have 4 inequalities, 4 constraints, so we will have 4 slack variables. So we've got x1, x2, x3, and then we'll have slack 1, slack 2, slack 3, slack 4. So this should be 1, 0, 0, 0. And then we need a column to represent our objective function. Now remember, our objective function right now is w. So we'll have a 0 here, and then we'll have our constants on the other side. So we'll have 72. So now let's see, our second constraint will be negative 1, negative 3, negative 2, 0, 1, 0, 0, 0, negative 40. The third one will be positive 3, positive 1, positive 5, 0, 0, 1, 0, 0, 56. And then the next one will be negative 3, negative 1, negative 5, 0, 0, 0, 1, 0, negative 56. And last but not least, we need our W row. And so, remember, when we write W, we're really saying we're moving the W to the same side as the x1, x2, x3. So we have negative 7x1, negative 3, we're going the other direction. Not moving W to the x's, but moving the x's to W. So we have W plus 7x1 plus 3x2 plus 5x3, and this equals 0. So our coefficients in that bottom row are all going to be positive because originally in our W function or equation, they were negative. So we'll have a positive 7, a positive 3, a positive 5, 0, 0, 0, 0 until we get to W, that'll be 1, and then 0 in the constant. And so this would be our initial tableau. All right. So the key thing that I want you to take away from this is the goal when working with a non-standard minimization or maximization problem. The general goal is to create a standard maximum. Okay, unless it's a standard minimum, you're pretty much doing trying to create a standard maximum every time. You do this by manipulating the inequalities, so you may have to multiply by negative 1 to change the direction, or if you have an equal sign, this will become 2 inequalities, and it will always be, whatever you had before, less than or equal to the number, the constant, and then you'll also have negative whatever you had before, less than or equal to the negative of that number. So that's what we saw down here. We had exactly what we started with, less than or equal to 56, and then we had the opposite of what we started with, less than or equal to negative 56. So that pattern is going to be the same every time. Once you've got the problem written as a standard maximum, then you go ahead and put it into the tableau. Now, in the next video, we'll talk about how do we actually go about solving or applying the simplex method to this type of problem, especially because we have these negatives over here, and so those can cause some problems.